Well, this is going to be a good video. This is the heart and soul of some of this early algebra that we're doing. Today we're going to talk about solving equations, how to solve an equation and how to show your work so that it cleanly can be read by others. Equations basically come down to sort of two major ideas. Number one, we want to talk about equivalence, staying balanced, as I like to say. Anything we do to one side of an equation, we just have to stay balanced. We have to keep it kind of that same way on the other side of the equation, or often what we call these properties of equality. We'll get back to those when we get to this next page of notes here. But the properties of equality basically just say if we add, subtract, multiply, or divide on one side, then we have to do the exact same operation on the other. Now, which operation we want to do depends upon what's already there, and that's where the inverse property can come into play. So again, equivalence and inverses. The inverse property just says that any operation that we do, we want to use to undo sort of another operation. So let's just start solving. Down here at the bottom, we've got some equations, and we want to make sure that we show our solution steps. So again, I'm going to demonstrate how to properly show, or at least one method of showing, our work. So over here in the upper left, we've got x minus 5 equals negative 13. Well, if we have subtraction going on the left side, I want to figure out what x is. So I need to get rid of that minus 5. If I can get x by itself, then I know what it's equal to. Well, let's add 5 then, because minus 5 plus 5 is going to cancel away. And basically x minus 5 plus 5 just becomes x. But again, that equivalence idea, anything I do on the left, I need to do on the right. Anything I do to one side, I do to the other. So negative 13 plus 5 on the right side of my equal sign is going to become negative 8. And now if I took my negative 8 and I plugged it back in, I could plug that in for x. Technically, we could check our answer as well. So we could say, is negative 8 minus 5 equal to negative 13? And since negative 8 minus 5 is negative 13, I would say that negative 13 equals negative 13, and we've checked our answer. Again, we always want to write out both sides of the equation because that's going to be very helpful for us. On the left here, though, that's our answer. So don't forget to go back. Now that we know it works, x equals negative 8 would be our solution. Let's see if we can use that same idea down here at the bottom. Notice we're multiplying by a negative 4, right? Negative 4 times x this time. So to get x by itself, I'm going to divide by negative 4. Divide by negative 4. And again, if you want to write the division symbol, you can. Sometimes it gets a little bit messy with plus signs. Division signs can kind of look alike. And or with division signs and negatives, sometimes things get a little messy. So I tend to write them as fractions. Negative 4x divided by negative 4. Well, our negative 4's will cancel each other away, right? And if you want to, you can sort of slash those away, which leaves me with just x on the left and 16 divided by negative 4. Don't forget to carry that equal sign down. 16 divided by negative 4 is negative 4. And again, I could double check that by saying original equation, negative 4 times x would have been 16. And I'm going to plug in, again, I think my answer is negative 4. Negative 4 times negative 4 is 16. We already have 16 on the right, and our answer checks. So again, don't forget to box our answers. Now over here at the right, subtraction isn't really that difficult, but we do want to do a little simplifying. Notice it looks a little bit messy on the right side there. N minus the negative 4 could really be rewritten. Remember, minus the negative can really become addition. So I would actually rewrite this before I even start solving as just n plus 4. And minus the negative 4 is really the same thing as adding 4. Let's simplify that, right? Get rid of those extra stuff. Those negatives are gone, the parentheses are gone, and now I can solve. I'm going to subtract 4 in order to cancel it. So I have to subtract 4 on both sides. And basically I will end up with, on the right side, I've got n, right? N plus 4 minus 4 is just n. And on the left side, I've got my negative 12. And again, we could double check our answer if we want to. Negative 8 equal to is negative 12 minus negative 4. So I'm going to go ahead and just call that plus 4. Well, I would actually say that yes, negative 8 equals negative 8. And therefore, again, we get our good answer. Don't forget to circle it. Finally comes this division down here. Now, if you wanted to rewrite this, you could. Technically, 1/5 times x is the same thing as x over 5, which just reminds us, well, how do I get rid of a fraction? Well, I really need to cancel the denominator. Same idea over at the left. How do I get rid of division? Well, I really need to multiply by the denominator, right? 5 over 1. 5 on the top is going to cancel that 5 on the bottom. So on the right side, 30 times 5, right? Again, that's going to cancel these two 5s over here at the left. And we're going to get x equals 30 times 5 would be 150. Right? And if we went to check our answers over here, we could also say 1/5, right? That was the same equation, times 150 equals 30. Well, if we check it on our calculators, 1/5 times 150 is definitely 30. Answer checks. And again, notice we've already circled x equals 150. Note the solution steps. You need to show your work. So these plus 5s, right, that we have in here, right, on the first problem, or the minus 4s, right, on this problem. You got this equation here. Oops, and the solution steps, though, would be those minus 4s. We need to be writing all of these things so that we're showing others how did we solve it, not just writing down final answers. Now, taking a look at a couple more. Again, we noted this problem already, or these problems already. Again, these properties of equality can also help you when you're talking about fractions. It's not about what the numbers are. It's about how we're going to get rid of them. So on the problem on the left, we've got x plus 1/4. And feel free to pause the video, by the way, if you think you can solve these. Take a second, pause the video now. Otherwise, I'll start up here in just a couple of seconds solving them. What I'm going to start off doing is subtracting that 1/4 from both sides of my equation. Now, that gets a little bit tricky, only in that plus 1/4 minus 1/4, again, is going to nicely cancel away, right? We'll get rid of those numbers. But now I need to remember, how do I subtract 7/8 minus 1/4? Well, I need a common denominator, so I'm going to make that 4. I'm going to multiply by 2 top and bottom, right? 1/4 times 2 over 2 becomes 2 over. So again, I'm subtracting, right, is what I was doing. But 1 times 2 would have been 2, and 4 times 2 would have been 8. So basically 7/8 minus 2/8 is 5/8. I'm going to leave that one to you to check your answer. But I'm pretty confident 5/8 plus 1/4 is 7/8. Then over here at the right, kind of the same idea. I've got a 2/3 x. Well, if I'm multiplying by 2/3, I could divide by 2/3, and I want to divide away that negative as well. So I can divide away that full number. But now remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So again, I'm going to leave x over here on the right, but 10 is really being multiplied by the reciprocal, negative 3 over 2. Right? Flip that fraction over. 2/3 becomes 3/2. And so now when I multiply, I'm going to get an answer of negative. Again, 10 times 3 would be 30, divided by 2 is 15. Or you could have taken 10 divided by 2 is 5, times 3 is 15. Either way, I'm going to get a negative 15 for x. And again, I'll leave that one to you to check the answer. But there were some couple of quick problems right there for you dealing with fractions. Remember to stay balanced. Final two problems, just a couple of word problems, and I think we can do these fairly quickly, so I'm going to kind of tear through them here. You've got a basketball pole. It's 14 feet long for the pole, but realize the pole is going to go into the ground a little bit. So we know that we've got x feet below the ground, and we know we've got 10 feet above the ground. So if we write an equation, well, x plus 10 should equal the grand total of 14 feet long for that pole, which means if I subtract 10 from both sides, x equals 4. And we know that 4 feet, right, of that pole are underground. Same thing goes on the right here. Your bank balance is $42. You're going to buy a pair of shoes, and that's going to leave you with $11. So let's set up an equation. What I would set up for myself anyway is that 42 minus x equals 11. Grand total of 42 minus the price of the shoes, going to leave us with $11. Well, in that case, again, I could subtract 42 on both sides. Now notice the 42 and the negative 42 cancel, but that leaves us with, don't lose that minus sign, a negative x. So you might have kind of wondered, well, 11 minus 42 would be negative 31. Well, price of the shoes can't be negative $31. But remember, in the end, I still need to get rid of this negative. So if that's a negative 1, I'm going to divide away negative 1 on both sides. And x will equal 31. Therefore, $31 is the price of the shoes. I hope that helps you with solving equations. Ask your teacher if you have any questions. Otherwise, good luck and have fun.